Thinking Aloud. Conversations on the leading edge of knowledge and discovery with psychologist Jeffrey Mishlove.
Hello and welcome. I'm Jeffrey Mishlove. Today we are going to explore the reality of possibility. With me is Dr. Ruth Kastner, a philosopher and physicist. She is on the faculty of the State University of New York in Albany and is also a research associate at the University of Maryland in College Park. She is the author of The Transactional Interpretation of Quantum Mechanics, The Reality of Possibility, and also Understanding Unseen Reality, Solving Quantum Riddles. Welcome, Ruth.
Thanks very much. It's great to be here.
It's a pleasure to be with you. When I think about unseen reality and the reality of it, right away I begin to think of Plato and the famous analogy, the Plato's cave, that there are realities that are maybe much more real than what we consider solid, but we can't see them directly.
Yes, I mean, Plato had an interesting story that you just referred to. I guess we can review it very quickly.
Good idea.
The idea is, as a Plato's cave, is that there is this cave with a deep chamber where there are these prisoners who are chained, such that they can only see one wall, and they're constrained that their heads can only turn this one way and see this wall, and they're watching some shadows on the wall, and they can see these shadows, and for them perhaps it's a lot more interesting than the floor of the cave, so at least there's something for them to see, and since that's all they can see, that's their entire reality, and they have no reason to think there's anything else.
Shadows of themselves, presumably.
Perhaps,
there's like
yes.
A fire behind them.
Right,
something.
There's a fire behind them, and as Plato tells it, besides just themselves, because there's this bright fire at the mouth of the cave, behind that fire, or just between the prisoners and the fire, or the bright sunshine from the mouth of the cave, there are people walking behind the prisoners, perhaps with jars on their heads and interesting statues. So there's a lot of interesting stuff going on the wall, these shadows. But since the prisoners can't see where those shadows are coming from, and they can't turn around, they think that those shadows are the entire reality.
Yeah.
And nevertheless, as Plato argues, using Socrates as a metaphor for the one prisoner who escapes his chains and goes and explores and finds that there's more to reality that the other prisoners couldn't see. Of course, when he returns and says, "Hey guys, there's this whole amazing reality out here," they think he's crazy, and they kill him, right? So this is where we are in a sense with empirical science, where we're in the space-time theater, if you will, where we use our five senses to make measurements and to be able to come up with scientific theories. But I would suggest, and I've suggested in my books, that perhaps we're at the threshold of where quantum theory has brought us to the threshold that we may begin to legitimately ask, are we actually in a form of Plato's cave here? And is there more
Now,
going
Plato
on?
had many other arguments to support this analogy.
Sure.
I mean,
right.
For example, we talk about in geometry the Platonic solids. And
Yes.
basically, if I understand philosophy correctly, Plato is arguing that the realm of geometry, the realm of pure, perfect geometrical figures that are so perfect they don't even ever exist in the physical world, that's the Platonic realm. That's a very real realm.
Yes, for him, he felt that there was this realm of perfect forms. He was what you would call a rationalist, because he believed that we gain knowledge about reality by using our mind, by using rational thinking, and not everyone agrees, but you know, that's a philosophical discussion. but he did believe that ideas such as this had their own form of reality. And as you say, there was almost a whole moral dimension to his thought, where he viewed this world of perfect forms as almost the morally perfect realm as well, and that the a world of appearance, the phenomenal realm that we experience with our five senses, was always flawed in some way. So as you said, the perfect mathematical concepts could never be manifest here.
Now, I think it's fair to say that there have been schools of thought ever since Plato, Platonists, who believe that there are unseen realities that are very real. And my understanding is that today most mathematicians are Platonists.
I think so, yes, that they think of mathematical ideas as having their own reality. And of course, it's always very intriguing. I think it was Eugene Wigner who pointed out the unreasonable effectiveness of mathematics in the sciences. Yeah. Why is nature mathematical? Why should that happen at all? That it just so happens that if we apply mathematical constructs and mathematical reasoning to our empirical observations, we're able to predict new things. So that in itself is very surprising, and Einstein also observed that too. So that's an argument, as you say, for thinking of mathematical form as having some aspect of reality.
But when you suggest, as you do, that the very well-defined probability clouds of Schrödinger psi waves of quantum mechanics are real, you're going a little bit beyond the Platonic perspective, aren't you?
I think so, and of course, Plato didn't have quantum theory in his time, so we wonder what he might have said.
Yeah.
But one thing that makes quantum theory so difficult to interpret is that the mathematical form of the theory does not straightforwardly refer to concrete space-time things. I mean, in a quantitative sense, the form of the theory has too many dimensions. It's got this complexity in that it involves imaginary numbers rather than only real numbers, and it actually literally has a multidimensional character that we know space-time has 3 spatial and 1 temporal dimension.
Yeah.
So if we take quantum theory as referring to real things, these things have much too many dimensions to fit into our space-time.
And in that regard, you refer back to the 19th century parable of Flatland,
right,
which does sort of argue that there are parallel dimensions.
Well, that's a lovely story because it's all about, not only was it a satire on Victorian social mores of the time, but it's also making fun, I think, of some of our inability to sort of think outside the box. We have our world of appearance, which I argue that's the space-time realm. It's the world of appearance.
3 dimensions of space and 1 of
plus
time.
1 of time, right. And there's no reason to think that that's all there is to reality. And a vivid way of seeing that is, as you said, with Edwin Abbott's story, Flatland, because he talks about a bunch of shapes that are stuck in a plane, in a 2-dimensional surface, and that's their whole reality.
That's Flatland.
That's their world, right. So that's the sort of Plato's cave, those are their shadows on the wall. Those are the only things they can see with their senses.
Yeah.
But then mysteriously this higher dimensional visitor comes in one day and causes a lot of trouble and causes this guy who's a square, one of the inhabitants of Flatland, to start seeing some very strange phenomena that he can't explain if everything is confined to a plane. And I've argued that that's what quantum theory is doing. It's saying, ooh, here's some weird phenomena, the non-locality and so on, which we can talk about more, but these strange phenomena that seem to, or strange concepts that quantum theory seems to force on us, I've argued are evidence that there are these other higher dimensions that are real, even though they don't fit into our world of appearance.
I mean, string theory, for example, I believe refers to 11 dimensions of space.
Right. Now, and that's actually something where I would argue that we don't need string theory, but that's a different discussion. But similarly, you have many physical theories that involve many more dimensions than space-time. And if we're going to take those theories as referring to something real, then we need to allow for the idea that reality is bigger than we thought.
And the metaphor of flatland sort of suggests what it might be like for a being who can consciously exist in more dimensions than 3.
Right, right, and therefore has a lot more degrees of freedom, ways that he can move, things that he can do, and perspectives.
Yeah.
He has got a bigger perspective than the people who are just confined to flatland.
I mean, my understanding is that most indigenous peoples around the world implicitly accept this idea of that there are higher dimensions of space that are real, and that's where they attribute, spiritual beings.
Well, yes, and I mean, I'm going to be, my own work, my interpretation doesn't take any position on those ideas, but you certainly have to be impressed by the fact that there have been, since ancient times, people have had intuitions or some kind of inner experience that suggested some form of reality that is not contained within the reality, the world of appearance is what I call it, the phenomenal realm that we get information about only through our 5 senses. So, my interpretation doesn't depend on saying anything specific about those experiences, but certainly it's reasonable to think that people have had inner experiences that are not the external 5 senses. Because in Flatland, for instance, you've got the square, and from the vantage point of his visitor, the sphere, who lives in 3 dimensions, the sphere can poke the square in the stomach. So from the square standpoint, he's getting an inner experience. He doesn't know where it comes from. It's mysterious. So in a sense, any being that's confined to a particular lower dimension can be contacted from a higher dimensional realm, just in a geometric sense, and will perceive it as coming from their interior.
The higher dimensional being can, in effect, walk through walls.
Right. Yes.
Things that might seem magical in 3 dimensions become doable in 4 dimensions.
And become completely normal.
Yeah.
Right, completely normal once you're in a higher dimensional realm.
Well, let me try and get to a deeper issue, one of definition, I guess. When you talk about the reality of possibility, what do you mean by real and reality?
Okay, well, what I'm saying is that I think that the quantum formalism, we have quantum states that we use to label quantum systems, and it's these states that have this higher dimensional character. And so I'm simply saying, well, look, if they are something real, they aren't concrete actualities, meaning they aren't things like the chair. They aren't things we can locate in space and time. But I'm taking them to be real because I'm realist about quantum theory because it works so well because it's referring to something real. So I'm suggesting that we need a new metaphysical category for quantum systems because they are defined by this higher dimensional, multidimensional object. So they themselves must have some higher dimensional character, and clearly it's more fluid. We have many different possible outcomes when we make a measurement on a system. They can't all happen, so they can't all fit into space-time. So that I see them as possibilities, and I see them as real because we can create them in the laboratory. We're constantly doing experiments with quantum systems. Hey, turn on that laser over there. Okay, here comes a photon. All right, well, our quantum probability rule applies to that photon, or an electron, or other kinds of particles. So because we describe these particles by these higher dimensional mathematical objects, if they're real, they're not fitting into space-time. They're like that sphere or higher in Flatland. They're hovering out there somewhere ready to be manifest in our Flatland, if you will.
Now, my understanding is that there, I'm going to say roughly 30 or 40 different branches of mathematics that are now being applied to quantum physics. Strange things that I don't understand, twisters and gauge theory and
projective geometries
and Coxeter diagrams and a huge variety of very specific, very precise mathematical objects.
Yes.
that are found
Yes.
to be useful in interpreting various aspects of quantum theory.
Right. Now, of course, I mean, I couldn't comment on the specific models that I don't know about because, for instance, I'm a little bit of a skeptic about string theory, and I'm certainly not an expert in string theory, but I do understand that it's developed to try to solve the quantum gravity problem, and I think that there are other ways to solve that. But clearly, there are many different kinds of models we can construct that who knows may turn out to be fruitful. And in that case, we might say, look, that odd mathematical construct that someone came up with turns out to have a physical correlate in reality, which is fascinating.
I mean, just as Plato thought that geometrical objects are real, many of these hyperspace objects could also be equally real.
Right, right. If a model turns out to invoke these kinds of mathematical quantities and it's found to be fruitful, maybe predicts new things, then it suggests that that's describing something about nature.
But that's your test. It has to have some sort of heuristic validity.
Well, I mean, we have so many competing models, and part of that is because there is disagreement about how to interpret quantum theory and how to understand the role of gravity in context of quantum theory. So we have many competing models, and ultimately down the road the tests will be there are many different ways to say, well, what's a good model, and that certainly remains an object of further discussion. But certainly if it's fruitful, I mean, in my view, if you have an ad hoc rule that was just sort of arrived at because someone kind of guessed, like the probability rule for quantum outcomes. What I like about the transactional picture is that it explains where that rule came from physically. So for me, that indicates that the transactional model is bearing fruit, perhaps after the fact because you already had this rule, but you didn't know why it worked. So to me, that's an indication that you've made progress in understanding.
Now, you're a proponent of the transactional interpretation of quantum mechanics.
Right.
And that interpretation, as you express it, is willing to grant more of a sense of ontological reality than some other interpretations.
Right. It's a realist interpretation. So it does take the quantum formalism as referring to something real in nature. Yes.
Even if it's not observable.
Right, exactly.
And
yes.
as we get into the details of the transactional interpretation, what we see are signals coming both from the origination of a particle and from some point in the future, I suppose, where the particle is absorbed or perceived.
The way I would describe it is that these are influences. They're sub-empirical. So I wouldn't use the word signal because usually that means a controllable, observable signal. But that there are physical processes that are in play, and there are both processes in which an emitter gives rise to an influence, but absorbers also respond to that and give rise to a responding influence. And that is path-directed. That's what they call an advanced solution.
So in other words, an electron is emitted, or a photon is emitted from an atom. We don't know where it's going to end up.
Right.
There are many probabilities as to where that photon will eventually be observed. But even before it is observed, the absorber, the point at which the observation takes place, is somehow reaching out.
Exactly, and in fact, many absorbers. In general, there's one emitter, say one excited atom, that's about to give up a photon and have the electron fall down to a lower state. And in fact, there are many other atoms that could take up that photon, that could respond to it. And the way I like to try to convey how this goes on is thinking of a movie. If you're filming a movie, you've got a lot of behind-the-scenes activity. So you've got actors, you've got the set, you've got a director and a producer and so on. This is the level at which those transactional processes occur. So you've got, say, the director sitting there with this little megaphone saying, okay, you go over there, I want you to walk from here to here. Now, you see one of those chairs? Okay, I want you to decide which one to sit down in. Any of those chairs is in play. You can think of those chairs as the absorbers, if you will. They're all potentially in play, and we can experiment and we can decide which one of those chairs, it's a bad analogy, but just to give the rough idea that those are a possible site for the actor to end up at. And perhaps we haven't decided until at some point we try many different things, many different chairs are in play, and then the director says, okay, I think you should do the middle one. And then they film it, and that's space-time. The result of the film is what actually happens. But the emitted person, if you will, the emitted actor who's going to sit down in one of the chairs, had any of those chairs in play, and they were very much part of the process of giving rise to the eventual scene that got filmed.
So behind the physical appearances, you and I, for example, sitting here in these two chairs in this studio, there could be a wide range of unseen influences. Like, what are we going to say next? And how am I going to respond to what you say? And what's the most important question? That's all going on. It's all very real, but unseen.
Exactly. There's all these possibilities out there, and each one of us has our own point of view, and from the transactional picture, each one of us is serving our senses, our absorbers, if you will, that sort of ended up being the chosen absorber. They all participate and they all respond in a sense, but only one of them sort of wins the competition, and that becomes, where a photon got emitted, say, from one of the lights, and may have ended up here, but instead it ended up in my eye, and so I get a perception of a light.
So if I'm a photon,
right.
If I'm a photon, I've just been emitted from an atom. The atom got excited and kicked me out. Now I'm being influenced by potential absorbers in the future, and they're all kind of beckoning to me. Right.
And this is all happening at a level beyond, at a sub-empirical level. It's not happening in space and time, because that's the only word we can use, because it's not empirical. You know, it's behind the scenes. And technically, actually, if you go to the relativistic level, you as a photon won't even be emitted unless there are absorbers participating. It's a collaboration. It's almost like, ooh, I see an unstable atom there. Wouldn't you like to go somewhere else? Well, you could come here. No, you could come here. No, you could come here. And they're all chatting about it. Metaphorically speaking, this is all going on. This is all, would go on at the level of virtual particles, if you will.
Virtual particles.
Yeah, that's if you get to the relativistic level.
I know we were not necessarily planning on talking about virtual particles, but since you brought it up, we should at least define them.
Okay, at the relativistic level of quantum theory, when you're dealing with higher energies and higher speeds.
Close to the speed of light.
Yes, you have to take into account that particles can be created or destroyed. You don't just get an electron plodding along here. An electron is almost surrounded by a cloud of what's called virtual photons, and that's why it's a charged particle. So we go to those finer levels, and at that level, at the relativistic level, a charged particle is in constant sort of communication with other charged particles through virtual photons. It's almost like, I like to think of it as, I don't want to get too esoteric here, but it's like a field. It's spread out, okay, the electromagnetic field. And it's like you've got a violin, and it's like a resonant chamber. So suppose you've got a violin sitting here and you don't actually bow anything, but it's a resonant chamber. So if you've got some little vibration in the environment, that violin may be excited slightly.
And I gather that this level of virtual particles is even deeper in reality than the level of the probabilities we were discussing earlier.
Right. It's sort of where those possibilities come from. Right. So the virtual particles are really just a kind of a way in which charged particles, the virtual photons, are the way in which charged particles kind of know about each other.
So they're mathematical models that are very useful in quantum mechanics that describe these so-called virtual particles. And this is probably an area where physicists will say, shut up and calculate. Don't worry about what these virtual particles really are, because they don't need to exist.
Yeah, a lot of people say, well, that's just the perturbation expansion, and don't get realist about that. But in a sense, if these things work, perhaps they are describing some aspect of nature. So, I mean, I think of them as these connections between the charged particles that allow them to know about each other.
Well, one might say then that there are different levels of, I'm going to use the word subtlety.
Sure.
With regard to this unseen realm.
Sure. Yeah.
And that quantum physics gives us a way of beginning to develop structures to begin to think about those levels.
Right. I would agree with that. But when you were saying, that you as a photon could be emitted, that's just kind of it's always a two-party thing, or it's a multiple-party thing. In other words, the insight, I think, of the transactional picture is never the case that an electron just kind of goes out and does something on its own. It's always a participatory thing. There's always an emitting system and many possible absorbing systems that are interacting with each other to give rise to this what's called an offer wave. That's John Kramer's term for the usual quantum system. And then the advanced response that absorbers contribute is called the confirmation wave.
The offer and the confirmation.
Right.
But in human terms, for our viewers who are not quantum physicists, it suggests that moment by moment we're being influenced by both the past and the future.
Well, certainly quantum systems are, and now it becomes another question as to what's a human agent. Clearly, our bodies are these concrete objects like the chair, but we also maybe have a mind too. Is our mind a quantum object? There's you could spend a year talking about that question in itself. But certainly a quantum system is an object that is kind of tied in a sense to that which emitted it and that which will absorb it, and many other possible absorbers too. It's like a tug of war. If you think you're the quantum system is like the rope, and you've got a bunch of people on one end and a bunch of people on the other end. It's like a mediator. It has to connect two things. It's never just something that's just kind of going out and. It's never autonomous. It's always
and the normal notion of causality always going in one direction. Are you challenging that notion?
Well, in my approach, when you have an actual transaction and something happens, you've actually generated space-time events, and you've created a piece of the fabric of space-time. And that has established an emission in the past and an absorption toward the future direction of that emission event. So in that sense, the emission always happens in the past relative to any absorption.
Right.
But my model doesn't say that the future already exists. My model says that the future is just possibilities. So the future is continually being created. But once it's created, it is the future that's being created. It is, in a sense, my picture actually has the present always there, and the past is falling away from us. So as conscious beings, perhaps, we're just always in the present. And if you think about your own experience, that's what you experience, right?
Yeah.
I'm never in the past or the future. I'm always in the present. But I can have an experience that events fell away from me, from my perspective.
Yep.
I can think about them in the past, but the future's just possibilities.
Okay, but there is a sense in which at least the most immediate future is a little more tangible.
Right. Although I would say that the future is always possibilities.
Okay,
Yeah.
well, Ruth Kastner, we're a little bit over time, but thank you so much for this very informative discussion.
Thanks, it's been a pleasure.
And thank you for being with us.